please. Just don't make it weird. Don't make it weird. Here we go. 7.2, elimination. Elimination, what's the point? Oh, come on. Such an easy question.
Make one
To eliminate.
To eliminate! Exactly. To eliminate what? Let's talk about it.
A variable.
A method. Now, hold on. What's so interesting about what this method is for and the two examples you just saw?
Solving linear.
It says this is a great method for solving linear systems of equations, which is why you learned them in Algebra 1. So what we have to figure out, even though you reviewed it again in Algebra 2 with me or with Mr. U, does this apply to nonlinear? Who is this guy? A quadratic. Why? Only 1 squared. Who's this guy? Circle. Because it's x squared plus y squared equals r squared. Remember we reviewed that last time? Who's that guy?
Straight line.
Exponential. Swoop. There he is, right? What's that guy?
Linear.
Now, does this make this a linear system?
No.
No, because I got the swoopy guy
What would
too.
that have the tangent line?
Ooh. Snazzy. Snazzy. But what are we asking ourselves? We're saying, okay, this is great for linear systems. Does it work for others? And the answer is going to be basically sometimes. So yes, the goal is to eliminate. Oh, look, you already wrote it down. Oh, and some of you missed it. Okay. I know, we've had a very distracted class. Here we go. We're focusing. We're focusing. The question is, the answer is sometimes. Sometimes helpful. What's that name for the ones that aren't linear?
Non-linear.
Hey, go team. And nonlinear just means you might have one line, but there's something else that's not linear. So some of you were like, ugh, what's going on with the table? And I said summarize, and some of you said, I can't, I'm too tired. Okay, for those of you that did summarize, what was the most important step for the method of elimination, or the most important information for step 1?
Obtain coefficients.
Keep going. Needed a little more information.
For x and y.
You don't get coefficients
Needed a little more
different
information.
in sign.
We want them to be the same. So we're doing coefficients that match, but are different in sign. So the same but opposite. Does that make sense? The same but opposite. Meaning the same number, or the same term, but opposite sign. So yes, number 1 is get coefficients for x or y. So get coefficients that are the same but opposite. And they would have to be like terms. So for linear systems, x or y. For nonlinear systems, maybe x squareds or y squareds. Maybe e to the x's or y's. I don't know. Like terms that are the same but opposite. Step number 2, what's the key?
Add the equation.
Add to eliminate. Now wait a minute. If they're the same and I add them, oh, but they're the same but what? Opposite. If they're the same but different, yeah, if they're the same number but different signs, if you add 2x and negative 2x, what happens? If they go away. So the whole key is, once again, we're going to be able to add to eliminate because we've made them the same but opposite. Step number 3 says what? Solve. Yeah, just, you have an equation, solve it. Using what? I don't know, whatever algebra, whatever pre-cal, whatever stuff you know to solve. Step number 4, ooh, Ryan, it's your favorite. Ryan Union. What's step number 4?
Back substitute.
So go back to something that you had earlier. But wait a minute, we didn't solve for anything, did we? So where are we back substituting? Because we don't have a place to back substitute into. For all of substitution, we had this nice little y equals x equals. Go plug in and you have it. Where are they telling us to back substitute into? Actually, no. We'll take what you got and go plug it into either of the first equations. It shouldn't make a difference. And guys, what's going to be this red star at the very end? Why am I still having you write down check? Even though most of you stopped checking things and answers a long time ago.
You never know extraneous.
You never know if it could be extraneous because we have weird functions that, do you remember from last time? When do we need to check?
Oh, when there's a limitation?
When the domain, yeah, when the domain has some sort of limitation, some sort of restriction, another way of putting it. when there's something that could not work. It could have snuck in our mathematical process of doing inverses. Okay. I actually want you guys for this page. This is preparing us for section, ooh, it's an interesting one. Is it 7.3 or 7.4? Wow, off the top of my head, I don't remember. But I want you to write down row operations. Now, this doesn't really have, this vocab, row operations, doesn't really have any application in some ways to elimination as you know it. Row operations doesn't exactly, that vocab doesn't exactly have any meaning to elimination as you know it. But it's preparing us for something called matrices. Now, just a few of you guys are interested in what's to come. Hoban was in here the other day and talking about, where's he going to apply? Caltech, I think. And he was mentioning like some of the classes that they might advise high schoolers to try to take, etc. Do you guys know there are other types of classes out there that aren't AP, but are actually higher for high schoolers?
Oh,
There is something called IB curriculum. International Baccalaureate. IB math. That's like a higher math program. Not higher as in AP goes really deep into some college level coursework for sure. But IB curriculum is like, hey, let's just actually get them started on college classes. Not all schools offer it. Not all private schools offer it. But there is a class that you could take that actually a lot of like computer science majors would need. Engineering majors would need. Math and statistics majors would need. There is a course that you guys wouldn't necessarily have on your radar because it's like in high school, you're in pre-calculus, so what course do you think this is preparing you for? Yeah, you would think calculus. Is it in some ways maybe preparing you for a stats class? In some ways. Not tons of ways, but some ways. It could be preparing you for a probability course. It could be preparing you for not just Calc 1, but also Calc 2 and 3 and 4 and 5 and 6 in some ways, But it's also preparing you for things like linear algebra, which is kind of in this other branch, this other direction. Linear algebra has a lot to do with matrices. And once again, it is very helpful, very fundamental for coding and programming. Not necessarily what you're seeing here, but maybe in some ways. But linear algebra, this row operation idea, which I know, once again, like Ryan came in and he was like, we've already done this. I know. But some of what we're going to talk about and introduce in elimination helps us form a foundation for these guys, and that in turn is the beginning of that dude. Tons of connections. Most of which some of you will never see, some of you won't see for a while, and some of you won't even realize I made them because you forget all about them before you ever get to that class in college. But let's just talk about, okay, elimination. You're trying to eliminate. What have you learned when you've done elimination? Legal operations, 2, ready? Entire equations. That's kind of the key. And by equations, I could be saying or referring to rows. This is where kind of they start to tie together. If I'm talking about an entire equation and another entire equation, or maybe even a third entire equation, I could think about them as rows. An entire row of related variables or related quantities. What is legal for me to do in any system is I can change the order of, change the order of the first, the second, the third. I can change the order of which one goes first, which one goes second, which one goes third. Totally legal to change the order And I have not messed up like the equality of my system. I can change the first row, interchange the first row and the second row, the first row and the third row. Totally legal to do that. You probably haven't done that before, but you could. You can also multiply an entire equation by a non-zero constant, which you guys always, well, frequently do with elimination to make, right? To make something be the same but opposite. We're usually multiplying a whole row by something. And then last but not least, we can add a multiple of one equation to any other equation. This is, in some ways, what you do in elimination, but just kind of showing you that this is a foreshadowing of other things to come. Well, let's go over here and say, okay, what if we were to talk about some interesting systems? Some interesting systems. First of all, if you didn't like that one being first, we could totally switch it. That's what the first row operation says. You can switch them if you want. Now, I can't go like changing systems. It's within one system, but I can put them in any order I want. Number one. Number two, if you don't really care about the order, I can multiply a whole equation by something. And remember my goal. Goal number one. Make something match but be the opposite. What do you want to multiply the first equation by? You have a choice, but choose wisely. Someone tell me something to multiply the whole first equation by that would be helpful in eliminating.
Oh, 3.
3, I would say you should not do. Negative 3 is an option. Or 16 is an option, because I want them to be the same but opposite or different in sign. Why? Because I don't want you guys subtracting. Why? Because so many poor little seals would die. Because most of you would forget to subtract every single term and flip every one to be the opposite. It's safer to add. If it's safer to add, well, so what do you want? Negative 3 or positive 16?
Negative 3.
Because you don't want to do that, right? Cool, sounds good. Negative 3. So I would go ahead and write my negative 3x squared minus 3y squared equals negative 75. Am I allowed to change the order to take that multiple to put it down here and do an addition? Is that legal? Yeah, because I can interchange the order. So I can multiply, I can interchange, and I can say, solve my system. And technically, I can also say that this system is equivalent to that system, which is nice. Or just think I kept everything balanced because I multiplied on both sides. So what ends up happening, cool kids? I am about to do, what's that snazzy vocab word?
Synthesize. Eliminate.
Eliminate. I am going to add. I'm not really bringing stuff from other sources, maybe not synthesize, but I am about to eliminate. And I end up with negative 19y squared. Ooh. Ooh. Am I allowed to do that?
No.
I have to be careful, it's not linear. Those are like terms, those are not. So I'm going to end up with negative 3y squared minus 16y. Would you have caught it?
Yes.
Why am I putting a plus 75 and an equaling to 0? I'm getting ready for factoring because I have a quadratic. Right? What's the really sad thing about what we're about to factor?
There's a 3.
There's no GCF. I wouldn't mind a 3 if that was a 15.
Oh, we have to like separate the 16.
So it's up to you guys. You could either be thinking of, hey, couldn't I think of all the different possible factors of negative 3 times 75, which is going to be 15, carry the 1, 225 with the negative. I could start thinking of all the things that go into 225. Not 2. 3 goes in 75 times. 5 goes in 45 times. What's the alternative? X or y equals negative b plus or minus square root b squared minus 4ac. Ew, ew, ew. Maybe we can find it? It would be possible. 6 doesn't go in, does it? Nope, 7 doesn't go in. 8, 9, 10, 11,
That's 15 going.
12. I was thinking 15. I think 15 goes in.
9 and 5.
It goes in 1 time, and then that's going to be 75, and 75 is going to be 5 times, right?
Isn't it 9 and 25?
Oh, I did miss 9. Did I even check 9? I went from 7 to like 8. Does that help?
I don't know.
9 goes in,
You do like
45, so that'd be 25.
that's so weird.
Ah!
4 plus 4 plus 4.
Now, remember, one more time, you could just be doing quadratic formula. But yes. What do we end up doing?
Negative.
I don't know.
Exactly.
Isn't it like
I
negative
just
3?
saw that you missed one.
You could go here and here, and you could go 9y minus 25, y plus 75, and negative.
What?
This is the old school way. Some of you guys said the star way, you could do like GCS, and do grouping. You could do the star way with 225 negative, trying to make negative 16. We figured out 9 and negative 25, and what goes on top?
3. The negative 3.
Negative 3 and a negative 3.
That reduces. It's 1 over 3. 1 over negative 3.
Yeah, negative 3 and 25 over 3.
So then I could have a negative y plus 3.
Yeah.
Right? So that'd be a negative 1 and 3.
Yeah.
So negative y plus 3. And then the negatives reduce. That doesn't do anything though. Let's check it. 3y plus 25. Negative 3y squared minus 25y plus 9y plus 75. Ha-ha! We got it. But why am I going to write 2 different order pairs and take what I would have gotten by subtracting 3, dividing a negative, so getting a positive 3, and subtracting the 25 and dividing the 3, getting a negative 25 thirds? What am I doing again and trying to remind you of? I'm setting them equal to 0, and I'm remembering that those are still both just y's.
You have to plug in the y's.
Mm-hmm. What's that snazzy term for going back and plugging in?
Back substitution.
Ooh, but where do I back substitute them into?
The first equation.
Well, technically, it doesn't say the first. What does it technically say in your steps? Either. So which one do you want? Okay. So plugging back into our equation, we could say x squared
One of them is 4.
plus 9 is equal to 25, and that is going to be the square root of 4, which is, the square root of 16.
Which is probably
Oh, yikes. Isn't that 2 answers in 1? Wait a minute. How many intersections am I going to have? I have 1, I have 2, and then theoretically, x squared plus 25 squared all over 3 squared. 3 squared is going to be 9. 25 squared. 25 quarters. How many dollars do I have?
Or you could just say
I know, I'm just being lazy.
6.
Is it 625?
Yeah.
We also do 25 times 5 times 5. 625. Equals 25. 25 times 9, I'm going to get nights. I'm going to get nights. So 25 times 9 is going to end up being 225. Hey guys, why am I going to see this and all of a sudden, pretty quickly, I'm going to say that, and I'm going to say this, and then I'm just going to end my little answer-y-do with that?
Extraneous.
there's only one solution. Wait, how'd you
No,
get-
there are 2 solutions, but why did I cross out that guy?
Because there's no. Where'd you get the 225?
Oh, I got a common denominator.
I was multiplied by 9.
Yeah, and 9 times 25 is 225.
Okay.
Because it's whole dollar, 4 quarters, and 1 more.
That number squared.
How would you have, yeah. Wouldn't you have subtracted 625 from 225?
Yeah, and then you can.
And you would have gotten a negative number, and Andy's thinking, right? What can't you do to a negative?
Square root.
So I said, it's not even actually extraneous, it's more just imaginary, Ryan, so I would just cancel it out. Extraneous is if it had worked, but I had plugged in and there would have been like a square root saying na. So there is a restriction in my normal solving, not technically extraneous, but it is definitely one to ignore and say there's no possible real answer for that y. So once again, sometimes in our solving, we get to something that's like, yay, it's an answer, and then we go check it out. So we're kind of checking, we're more just finishing. And it says, no, it's not. Okay. Now, quick question. Some of you guys said that you saw either this problem or something like it in homework where Sasha, you were allowed to use your calculator on something like this last night, right?
Yes.
That was the one you were asking me?
Yeah.
But what did we just talk about, the dilemma? Don't worry, you don't have to open your calculator. This wasn't a calculator question. Just work with me right now. What did we say needs to be by itself when you grab it?
Why?
And what's wrong with my equations? Now, is there a Desmos or GeoGebra that would let you just type it in as is? Yes, but can you use that on a test? No, so how could you use your grapher? Why am I going to do this big old square root with a 25 minus x squared to get the y by itself? Now, what was that cool trick? Because I would need a plus and a minus, but I really don't want to type the whole thing because it's exactly like the above. Did anybody try to do the negative and the copy pasting? Oh. It's not copying pasting like it is on the home screen because it doesn't highlight it. But is there another way to copy this into here?
Enter second
Put it as
answer.
a letter.
Not second answer. I don't think second answer works. You could try.
No, it'll
I don't
have
think
to
so,
last
because
time.
that's not an answer. It's just something that you typed in. But how can I do it?
Table. Your alpha
Not
table.
second. Alpha, not table. It's actually at 4.
Oh, table.
But I can go say, who's y1? That's y1? Sweet. Or you can just do that little square root. We saw that last time, just kind of reminding you.
What do you have a negative one?
Oh, because when I square root is squared, it's a plus or minus, like the plus or minus.
okay.
But I can't do a plus or minus in my calculator.
Like 12 squares.
Why is this one going to be 3x squared over 16?
Because you're subtracting the negative, or the 3x squared and then dividing by
Yeah, subtracting and dividing, and oh wait, a negative over a negative is a
positive.
positive. Okay, cool. Let's go double check our intersections real fast and make sure they work. Let's do graph. Oh, that's funny. Let me do a quick zoom standard. Yeah, there are only 2 real answers. And if we did go find one of them, just reminding you real fast how to use your grapher, we would do, yes, the blue. No, not the red. That doesn't intersect. I need the, yeah, I need the parabola. And then, whatever, close enough. Hit enter, it'll go there. Dun, 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 dun. We have it. And why are there 2? Because there's symmetry. But that's not the one that you guys were technically supposed to use your grapher on. I was just reminding you of some graphing calculator techniques, ways to be efficient. You're supposed to be doing this guy. So guys, what did you plug in? For the first one, y equals what?
E to the power of
Oh, that one's easy. Y is by itself. But how about the next one? Did you have to do some math first? Like, did anybody do the minus one and the minus? Wait. This was the one we did last time. It is a tangent. Good job, Jackson. Did you?
X plus 1.
Let's just be strategic, right? Let's be efficient. Let's not be stuck in the old ways, which said leave the y. It's like, nah, just move the y. Equality goes both directions, doesn't it? And y equals x plus 1, and we have our intersection point. Do you even need to use the intersection feature? Nah, because it intersects at the intercept, and the intercept is 1. So just reminding you guys of getting y by itself. And we did get to, I think I have the picture right here. Ha, there he is. Wait a minute, but what happens if you do use the intersection feature and it puts negative 3.586 e negative 7? That's not 0, and that's not 1. Remember, your calculator's limited. It's using lots of different techniques to get these answers. Higher techniques of higher math, but still approximate techniques. What does scientific notation mean when I have a negative number?
It goes left. Yeah, the left.
Go smaller. So I'm going to move 1 decimal place to get out of the 3, and then how many more? 1, 2, 3, 4, 5, 6, 3, 5. Your calculator did what it could, guys. What's my intersection point?
0.
Perfectly 0, perfectly 1. It does the best it can, and sometimes it falls a little short. Just a quick reminder. E is scientific notation. Scientific notation with a negative says move the decimal 7 places, so a 1 and 6 more. That is 0. That is 1. It did the best it could. Ryan.
So, I won. This is just squared. The blue line.
Say it one more time.
Is it just e squared? Because I put
No, it's e to the x.
Oh.
Yeah, e to the x. Where it's changing. Yeah, e squared would just be a flat line, so that would kind of mess you up. Andy.
Can I use it? Sure.
Yeah, phone on desk. No, when he comes back. I figured with that smile that I shouldn't be seeing because your mouth should be up. Okay, so next one. We're on 4 out of 7, guys. Here we go. Vocab. And lots of little baby systems. Vocab. And lots of little baby systems. P.S. Remember, we're kind of taking what we've already learned and we're leveling up, right? Let me give you guys a second to explore this a little bit. You have pictures on 2 of them. You have just the math on other ones. My question is, if you can figure out what the vocab means, my question is, with those examples, can you figure out what the vocab means? No one answer. I'm going to put a timer on. Let you guys kind of write down the slide, relax a little bit, just kind of look and explore. Maybe graph, but nah, I have to get y by itself. That's messy. I don't think I would graph. I think I would just kind of look at the math and say, huh, I've heard the word equivalent before. I wonder if I can figure out what it means in this case. Consistent versus inconsistent. What's going on there? Take your time. I'm not going to be saying anything. I'm just chilling. You guys can talk a little bit. But don't get too far off topic. Talk more about what you see as you write. Talk more about what you see as you write. Once again, just made a quick change. That word should not have been and. That word should have been or.
Is there like a name?
But you guys are writing them down and pondering. The other ones are all and. Only the first one was an or. Oh, it didn't go off. Oh, my sound must be turned down. Look at all that extra time you got. All right, cool kids. Which one's equivalent? The first one or the second one? For those of you that were in the recording, I took a little bit of time. They all wrote them down, and now they're pondering. They have been pondering. They're trying to answer for me. They're trying to answer for me what these words mean. Equivalent. What do you guys think? Equivalent. What do you guys think? Which system is equivalent, the first or the second? Oh, nobody has a guess yet? Ah, Sasha. Why the second one?
They seem the most alike.
Say it one more time.
They seem more alike than the first one.
They seem more alike than the first one.
Because if you multiply 4 on the bottom.
No, which system?
If you multiply 4 on the bottom for the first one, wouldn't it equal 20x plus 4?
Oh, yikes.
Yeah, there's something wrong.
There is something wrong. Man, this is rough. I'm sorry, guys.
The y's.
I don't know if I copied in the wrong example. That is not equivalent. Neither one is equivalent. So the correct answer to what I asked was technically neither one is equivalent. Can anybody help me make an equivalent one? Let's use the 20x. If it was equivalent, an equivalent system. I did mean for the second one to be the right one, but I must have copied and pasted the wrong thing, because that does not help. What would have been the y term such that it would have been equivalent? No? No? Oh, Sasha, say yours one more time. Yeah.
Maybe plus.
Actually, not plus. And then next would be 70, but positive or negative?
Negative.
So Baron and Paul, what are you seeing? Why is this one now equivalent when it wasn't before?
When you multiply the 10 each side.
Yeah, so what Paul noticed is that one is just 10 times the other one.
Yes.
Here's another way of looking at it. What would happen if I had gotten y by itself on the first one? Subtract the 2x, divide by a negative 4. You would have gotten 1 over 2x minus 7 over 2. What would happen if you got y by itself on the next one? Same thing.
Yeah.
Negative 20x divided by negative 40 would be 1/2 x. I know they look differently, but what are they in reality? equivalent. An equivalent system says we're not talking about two different things, we're only talking about one. An equivalent system says we're not talking about two different things, we're only talking about one. This one's not equivalent because those are two totally different expressions. Oh, interesting. What was there before? Why was I thinking like you guys? I'm sorry. Can we blame the lockdown drill? What was there before? Ah. Why was the and perfect?
Because they're not equivalent anyway.
What did I just describe?
Did there need to be
Consistent.
Did anybody notice what I just described? I just described consistent. I had the wrong vocab term in my brain. For some reason, I'm in Algebra 1 mode. I just described consistent. Consistent says, hey, they're multiples, one of the other. To where I could get this guy, y is equal to 2/3 x minus 1 when you subtract the 2x and divide by a -3. This guy would also be y is equal to -4x divided by 6, so negative 2/3 x. 6 divided by 6 is plus 1. Wait, plus 4x. Times a -2, times a -2, times a negative. Oh, there was a typo. See, I knew there was a typo somewhere. I just didn't have the right typo. Bummer, man. There we go. Without that little negative, it wouldn't have been consistent. Times a -2, times a -2, times a -2. That technically was inconsistent. Because it would have had the same slope.
Is consistent the same as equivalent?
No, that was my bad. So Ryan, what I was just saying was that my brain was somewhere else, and that I was describing to you guys consistent, and I wasn't describing equivalent. So that was my bad. And I'm saying the and is actually accurate, but why is the and accurate? Those of you guys that were saying multiply the 5 by 4, what were you seeing?
It will change it from the side to this.
I'm allowed to multiply or divide an entire row by anything I want, because division is multiplication by the reciprocal. 20 divided by 4 is 5, 4 divided by 4 is 1, -4 divided by 4 is -1. What is true about these two systems? Equivalent is a comparison word. Equivalent is a, hey, how does one system compare to the other? I was using it as an adjective for one. That's where my brain got messed up. Instead of remembering that it's a comparison word between two different, and not two different equations, two different systems. So these are equivalent because they actually end up saying the exact same thing. You could also see it as if I was to solve both this guy and that guy for y, they would both be y is equal to -5x minus 1. They would both be -5x minus 1 with the top equation that was the same. I apologize, guys. Whew, I got more thrown off by the lockdown drill than I thought. So equivalent is a comparison saying, oh, it's the same thing, just written a different way.
So, yeah, okay, so the top one is consistent? Or,
I used the wrong word. Equivalent says, hey, they mean the same thing. The two systems mean the same thing. Consistent is what I was describing when I erased it, when I rewrote it.
When you had to multiply by 10?
Yeah, that was consistent. Good. However, guys, it's not only consistent when they are the exact same thing. There's another case of consistency. So hold on. Consistency could be... It's too small. Consistency could be that they're the exact same thing, which in Algebra 1, does anyone remember, or even Algebra 2, how many solutions would I have for this guy right here? How many solutions? Yeah, Baron, what did you say? Infinitely, yeah. An infinite number or infinitely many? And this is whenever we have a true statement. So if we solve this system, we would have like 5 equals 5, or 2 equals 2, or 0 equals 0, and you're like, true. Oh, that's infinitely many. But what's different with this guy over here? How many solutions does this one have? Only one. Now, this one only has one. What if it was a parabola? Couldn't it have had 2? So I'm going to say finitely many. It could be more than one, because we're not just talking about lines anymore. Could be 1, could be 2, could be 3, could be 4, could be 5. But still, there's a certain number. It's not like a linear, where I only have 1, because I could have different types of equations that I'm trying to solve in my system, I should say. I could have nonlinear. But what's the difference between both of these that would call these systems consistent versus the anti, versus the opposite, versus the negative, inconsistent? What's true about how many solutions over here? Say it one more time.
No solution.
No solutions. I'm going to put none. Is that okay? Infinitely many, finitely many, or none. So what does it mean to be inconsistent? No solutions, aka no intersections. So I could say non-intersecting. Inconsistent means there is no solution to be found. The system is like, hey, this whole thing has to be true all at the same time. And we're usually, if we're solving a system, we're trying to find solutions. Well, if there are none, we'll call it inconsistent. Because it's not going to get us any solutions because of that parallel nature. Ryan, go ahead.
The one on the very left for A, it's infinitely many because like they're always like intersecting because they're
Yeah.
the same line.
And there are infinitely many points on a line, so since they're the same line, they're coinciding at those infinitely many points.
And then the other one, they only intersect at one point, so that's why it's
The lines will. Other might intersect in more points, but it's like a finitely many. But there are intersections. There are intersections. There are not intersections. Is that cool?
What about like under the equivalent one? Like if you were to solve one of them, I solved one of them and then I got like 1 point. Would that be one solution? Or,
If you solved one,
uh-huh.
that solution will be the exact same solution for any equivalent system. But it would fall under the consistent. It is a consistent one since you have a solution.
So would it, like if you were to graph it, would it be like, oh, it would be one of those points?
And we know
Because you
they're,
have,
well,
like,
because they're
2
linear.
points.
And so we know it's just good old-fashioned intersecting lines if you found one.
Okay.
If you got some sort of true statement, like if you were to solve this one, let me solve this one fast. Would anybody else use elimination and like, let's see, double everything? Is that cool? So if we were to double everything, because then the x terms would match, right? I would double the 2x canceling with the 4x. I would double the negative, that'd be negative 6y plus 6y. That's 0. And then 6 minus 6 is 0. Do you see my true statement?
Yeah.
So either I would have like an actual intersection point, like this one would end in 3, 1. That have me next class. Everybody just joining us. As you look at the screen, check out how I had incorrectly matched the equations in the systems with their graphs. For instance, this one at the very beginning. Remember I had to write that little negative 6 just a second ago? I'd actually matched it incorrectly, but it's okay. With the negative, we do get this true statement, which says that it is consistent with infinitely many solutions. They will coincide. You can also see that this guy is negative 2 times every single term once I made that change. But if you guys can take a second and look at your notes before we keep talking, I actually accidentally switched up my 2 different terms as far as it should have gone A, then B, then C, and then it was like a matching problem from the book that I incorrectly matched. So change up really quickly in your notes. C should have gone over there, B should have gone over here. And everybody that was in class today, we actually did some troubleshooting, which hopefully solidifies the idea for them. In the sense that, if I have consistent with infinitely many, I should be landing at everything canceling out. If I have consistent with finitely many, I should be landing in an actual solution, which I would be able to see on the graph. And then if I was, or if it is inconsistent, which we saw over here on the graph with none, what would happen when I go ahead and try to solve this guy? Well, I would end up with 4x minus 4x is 0, negative 6y plus 6y is 0, but 6 plus 6 is 12. What's going on with that statement, guys?
There is no solution.
There is no solution because is that true or false? It's false. So we had to use our algebra skills to be able to figure out, wow, those were matched horribly wrong. All of you guys that were doing all of the solving, excellent job. And I need to go back and fix the master for next year so this doesn't happen again. The math needs to coincide with the graph, and if the graph says I have an answer and the math says no you don't, well then I must have not put those in the right order. So either the book was off and it had A with 1 and B with 2 and C with 3, or I was off and it was a matching activity and I matched it wrong. But now we have the math totally coinciding with the other in that a false statement will lead us to inconsistent parallel lines. A true statement will lead us to consistent but infinitely many. Or it'll lead us to a solution that we could write down. We had the vocab right at the beginning, cool kids, in the sense of there are and there aren't, just I had the systems incorrectly matched. Now I would love to finish this section because I would love to go over WebAssign questions. If you guys have bathroom questions, just hold on until I change the screen, then put your hand back up. If you have on the screen questions, Andy, go ahead.
So for the
No, go to the restroom if you want to.
For the finitely many solution,
That just means there's like an actual
yeah.
number of them that I can find, which in this case was 1, and in this case was 2, and in other cases might be 3. But go ahead.
I was gonna ask on the graph, how do you figure out the x and y intercepts? Like for the points, because you know how you have like 2 lines and then you have 1 solution.
Well, I mean,
You have 3
if you were
common
doing,
lines.
you asked me for the intercepts. If you were doing the intercepts, we'd find 4 different intercepts because there are 2 different lines.
Oh yeah.
So we would just be plugging in x is 0, finding his, y-intercept, x is 0,
Oh, yeah,
finding
yeah.
his, and then we'd find both. And then
So
we'd find both.
if we wanted to like,
If we wanted them.
if we needed to graph it, we would
Plug in zeros, yeah. Yeah, if you wanted to graph it by hand. Or you could just, wait, couldn't you get y by itself and do y equals mx plus b? I mean, this is different, but I mean, I did get those into y-intercept or slope-intercept form. So there's the -1, and here's the rise 2, run 3. Well, actually, rise 2, run 3. So I could have done that. That's probably the easier way by hand. But guys, here's the last bit of today. It was a short section. Elimination was meant to be. It just got a little more mentally taxing than I meant it to. 2 slides, and we're done. The nice thing is, I know there are no typos on these slides. So take a deep breath, whoo, and let it out. Whoo. And then you can go the rest of the way. Applications, when, different questions? What's that thing?
No, I was saying I can wait 10 minutes.
Oh, okay. It's technically 11, are you sure? Just kidding. Applications, when does a problem involve a system of equations? Well, first of all, if we don't know more than one thing, I'm going to have more than one variable. And do you remember what I said last time when everything was a bit less scattered than today? Hey, chaos. How many equations do we need if we have 2 unknowns?
2.
3 unknowns?
3.
4 unknowns? Okay, so we need a system. We need more than one. If we have more than one unknown. So maybe we see that we have 2 unknowns, or 3 unknowns, or 4 unknowns. Well, we better go looking for more equations. Or, we also see that there is more than one condition or equation that has to be true. And that's exactly what we're going to see on the next slide. And that's exactly what we're going to see on the next slide. That's exactly what we're going to see on the next slide. And maybe you'll see both. Maybe you'll just see one. Maybe you'll see the other one. Those of you that have totally given up for the day, if I were you, just try to get this example down. Because it says, I have words. Ugh, where's the system? The system is so easy to see, even if they're matched wrong. It's easy to see their systems with the brace, but what if you have words and you're like, I'll help. But what's going to force us to make a system? It's going to say, well, we don't know more than one thing. And or there must be more than one equation or condition that has to be true. And guys, this is basically giving us just the beginning of like mathematical modeling. Taking a situation, breaking it down. What do I know? What don't I know? What do I want to find out? What are the constraints? That's a snazzy math word for this second thing right here. These could be constraints. If I have no limitations, if I have no conditions that need to be met, then nothing is constraining the problem. But either naturally or unnaturally or imposed. Once constraints are brought, well, all of a sudden I have some stuff to be plugging and chugging and considering as far as what could possibly occur. So more than one unknown or more than one condition. More than one unknown or more than one condition. If we were reading this problem, some of you are overwhelmed because it's a paragraph and you're like, ready? Summarize like you would any word problem. But maybe you don't know you should be doing this. Let me model it for you. What are we given? And what are we trying to find? Any word problem. Break it down. Don't write the paragraph unless you really want to. What are you given and what do you need to find? What kind of numbers?
Airplane travels 2,000 miles.
We know the distance is 2,000 miles.
3.
Careful, is it both ways? It says this distance, right? Down here on the return trip. I think it's both ways. I'm not saying in real life it'll always be the same distance, but in this situation, for sake of simplicity, have they given me anything else but 2,000 miles for going there and back?
2,000 miles.
Just 2,000
going
miles.
4 hours and 21 minutes.
And then, Andy, what you're telling me, that's a time, right?
Yeah.
So going the way there, what do you call it there? Return flight is return flight. What's the
Flight departure.
departure arrival? Oh, that's kind of
The
confusing.
departure of the
You have the time.
Departure and return.
Plane.
There we go. Should we use mine? 4 hours and 24 minutes. Ooh, I wonder why she's writing 4 and 24 60ths. And then back,
That looks like it.
That's like 100.
what do I want my units to be? Are you judging my 60? There you go. What do you want my units to be?
Miles.
No.
minutes.
Hours.
Why hours and not minutes?
Because you have the 4.
I have the 4,
Oh,
and I've made a fractional piece. Right?
can't you just change the 4 to 60 or like 60 times?
I think I could. Then it'd be what? 264 minutes?
Yeah.
Do that too. But question, do we normally put speed of an airplane in miles per minute or miles per hour?
Oh,
Maybe that's why I'm doing it. Okay, 4 hours. Okay. So I have a distance, there and back. Then I have there how long it took and back how long it took. What am I trying to find?
The distance. Return. Find the airspeed.
Oh, find the airspeed. Find, right? Look, it's right there. Find what? Find the airspeed of the plane. Give me a variable. What do you want to call it?
Can't you just divide 4 by 2,000? And then divide like each one and then times by 9?
Jackson, that would be great if there weren't two things at play. All of a sudden I need a system because there's not just the plane. They're saying we also have a wind component. Johnny, that was great. Let him focus though. Lance, I apologize. Pen out of hair. I think you wouldn't think you have to say an honors pre-calc classroom. Okay, so airspeed of the plane, airspeed of the wind. You guys good if I say find P? Is that okay for the plane? So the airspeed. You guys might not know there are 2 different ways of talking about the speed of the plane. They didn't call it speed. They called it airspeed. Interesting. And then W.
Because it's speed in the air. It's the speed of the air passing by. Speed.
What? Isn't that just wind?
Find the airspeed of the plane and the speed of the wind. Airspeed would be like in still air. Airspeed would be like in still air. Like what would the plane be flying if there was no wind? But the question is, was there wind?
Yeah.
Because what's it say?
Alright, buddy.
If you were running into a headwind, if you were flying into a headwind, if you were driving into a headwind, question, is it slowing you down or speeding you up?
Slowing you down.
Slowing you down, the wind is against you, right?
24 minutes.
If the wind is against you, well, there is some dynamicism, right? But wind is still going to have an effect. We're assuming also, they didn't say this, but we're assuming the wind hasn't changed on the way back. That's a big assumption. Right? Because time has passed, but assuming the wind is the same. We have to make two different equations because we have two different unknowns. Right? And behind all of this is an old school from physical science equation of distance equals rate times time, the dirt formula. That's what some people affectionately or not affectionately talk about. Another way of putting this, guys, is I have distance, I have time. What am I trying to find?
Speed.
Rate. I'm trying to find the speed. So I'm actually going to rearrange my equation and say, I want you. So I'm going to go ahead and set up a system and say, well, I have to have two different equations because I have two different unknowns, but what on earth would those things be? If rate equals distance over time, on the way there, guess what the wind was doing to the speed of the plane? It was slowing it down. Just being super basic here. But we're assuming that they are working directly against each other, like with vectors. If one's pushing this way, the velocity of the plane, and one is pushing that way, subtraction would tell me the overall result. The overall result is they got those 2,000 miles in 4 and 24/60ths of an hour. That was the result. Rate equals distance over time. But on the way back, we're assuming the wind didn't change. So P plus W, technically with vectors, if I wanted to make it spiffy, but I'll just leave it all simple and plain with little baby letters with no vector errors. I'm going to travel that 2,000 miles in only 4 hours. And all of a sudden, I have a what?
Two equations. You have a system.
A system, and a system that can be solved if I just, anybody want to do elimination instead of substitution? Because if you add down, what happens to your wind?
It cancels out.
Nice. And I end up with 2p is equal to, I'm adding down, right? 2,000 divided by 4 and 24/60ths
1,200.
plus 2,000 divided by 4. All I have to do is cut that guy in half, cut this guy in half. And I know some of that's easy and some of it might not be, so I'm just trying to be efficient with my calculator and hit as few equal signs as possible. So I'm just going to plug it all in and be like, all I need is a half of this whole mess. Ooh, and someone's already beaten me there. Go team. Let me just double check real fast. 2,000 all over 4 and. You guys remember mixed numbers is a plus, right?
Yeah.
4 and 24/60ths plus
I don't hear.
2,000 divided by 4.
Yeah.
And that's going to be which one?
I did it wrong.
P.
That's going to be P. So how am I going to find wind? And we're going to say, let's back what? Substitute into whichever one you want. And I don't know about you guys. I'd rather use that one because 2,000 divided by 4 is 500. So I can say that W is equal to 500. Take away P. Dun, 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 dun. I have my wind in my plane. Okay, guys, I apologize. Because of my mix-up with equivalent, consistent, and inconsistent, we did not have time for web-assigned questions. So please feel free to drop by during lunch or pop up here during nutrition if you have any questions on section 7.1.
Misty, when the 7.1 website interview?
I thought it was today 3:30. Is it? Do you guys have any questions on it? It's nutrition.
Can we go over 8?
Yeah.
Oh my gosh, number 8! I did that one.
Oh yeah, me and Andy did that.
Did what?
Number 8. Does that?
You're out.
You need that equation, Ryan, for simple interest.
500 is 2,000.
We don't. I'm not sure if there are any online equivalents. That's a good question.
So
But also for a lot of it, you have to make it kind of like the APs too, and so you have to have like a whole accelerated system.
She didn't even try to stop herself,
But,
she just took it. I was
we know that,
she just laid on the floor.
but we're talking about two funds. So all of a sudden I put some of the money in one and some of the money in the other. But total of them is 13,000. So I split up the 13,000 into two different amounts. Sometimes like there's like this one probably says I'll only take this much out, so there was a cap to it. But I also and this one is at 4%.
Like little brother like this on the end of it. Like I got the answer right there. I word credit.
Is it just annual?
Oh my gosh. She didn't tell us it was like that what was that? Answer and I was like, what class?
Remember, I looked
Like
all
if
right
it,
with the two big
even if you turn in the assignment like 2 minutes late, 50%.
What? It's very strict. No, she doesn't.
Literally, I turned it in one day late, 50%.
I still haven't turned any of my assignments, and I turned them in 2 weeks late. She gave me full credit.
Well, she must love you
No,
because
she hates it. But she was telling us the other day, I did that with all my classes except for physio.
I don't know. I need to talk to Gianni because I feel like everything is like we're literally doing that all the time.
My initial thought, Ryan, is just as easy
Like if
as
they just sent us the plays and we are done that, and give part of that.
it might not be having us do. Oh, this is compounded. They're not saying it's compounded.
And the paddle book was Friday.
So it's just like you'll get 4% after a year, which isn't very bad, but they're trying to make it easy, I think.
Alexis, how does Bible?
It was I think they would multiply everything by 100 just to make life a little easier.
Oh, you were
Right? It was bad.
This lesson is
I need to start doing the assignments I missed.
So if you want, you can do substitution, like solve for X or solve for Y, then plug in. Or like you could technically do elimination with like a negative 4. What is it?
Misty, is it all for number 14?
Let me get.
Yeah.
Anybody who wants to make up the forever quiz, give me a blank piece of paper now. Or forever hold your peace.
I know, because it like 15 times too.
So I have two unknowns, right? The X's and with the P's. So if I were you, I'd take X's and set them.
No, it was not a friend of mine.
My wrist hurts.
What did you tell him? Huh? Did you say anything? Okay. What did you say? I know, he knew something in fourth grade.
So I'm making this a system and I'm solving it for the marketing program.
Dude, it really needs to be.
Come on.
I will find it.
These want to set them equal to each other. Which, you want to foil it?
So I tried like sending it. Why? You know the weirdos thing?
Ditto.
I just took